Picture this in your mind's eye, a beautifully detailed 3D model of the Mercedes-Benz Actros, sitting against a sleek, dark gray background. Now imagine it smoothly disassembling right in front of us, rotating 360 degrees while its inner electronic modules start glowing under soft studio lighting. That's exactly how we're going to approach this explainer today. We are metaphorically taking apart this massive mechanical beast. By stripping away the steel and tracing these glowing electronic modules, we reveal a highly sophisticated, rolling digital network hidden inside. This isn't just a truck anymore, it's a mobile data center.
So, let's start by contrasting the clumsy, mechanical past with the incredibly sleek digital present. Think about old trucks for a second. They relied on these thick, heavy copper wire harnesses. We're literally talking about hundreds of pounds of just wire, right? Every single switch needed its own dedicated physical line. But the modern Actros? Totally different story. It uses ultra-lightweight, four-wire digital CAN bus networks, super-precise electronic stepper motors, and computerized high-speed screens. It's an absolute architectural revolution.
And the crucial technology making all of this possible is the CAN bus, or Controller Area Network. It's essentially this robust digital communication system that lets all the different electronic modules talk to each other and share data using just a few thin wires. The beauty of this? It dramatically reduces the vehicle's weight and drastically cuts down on electrical failures, which means way fewer unexpected breakdowns out on the highway. Think of it as the truck's central nervous system, literally replacing hundreds of pounds of copper with lightning-fast digital text messages.
All right, so here's our blueprint for today's explainer. We're going to break down the anatomy of this machine zone by zone. First, we'll look at the rolling computer network. Then, the powertrain and braking systems. Third, cab comfort and lighting control. Fourth, telematics and exhaust emissions. And finally, we'll wrap it up with the CAN bus symphony.
Let's jump right into Section 1, the rolling computer network, and meet the traffic cop.
Okay, so think of the Central Gateway Module, or the CGW, as the ultimate digital traffic cop. The engine network is out there speaking at lightning speed, while the interior systems are communicating on a much slower network. The CGW's job is to translate and route these messages safely between the two. Seriously, without this module successfully routing that data, your dashboard wouldn't even have a clue what your engine was doing.
Moving on to Section 2, powertrain and braking systems. Let's talk about the boss and the muscle. Now if we look underneath the chassis, you'll find an absolute alphabet soup of acronyms actually running the powertrain. You've got the CPC located in the cab. That's the boss, translating your foot's pedal push into a direct torque demand. Then there's the MCM, which manages the engine block. The TCM sits right there on the gearbox, handling the shifts. And finally, the EBS under the dash, which acts as the master brain for stopping. They're all totally independent computers, but they constantly rely on each other to get the job done.
And because of this setup, instead of using those clunky old mechanical linkages, a gear shift today is actually more like a simulated digital conversation. Just imagine the transmission module essentially texting the engine module saying something like, hey, drop the RPMs for a split second so I can slide this gear in. It's wild, right? But it allows for a perfectly smooth, clutchless shift every single time.
Now when it comes to stopping a massive 40-ton vehicle, the driver's foot is no longer yanking on a physical steel cable. Nope, it just pushes a giant electrical sensor. From there, the electronic braking system brain calculates all the heavy physics, speed, axle weight, and slip, in literal milliseconds. Then it sends a lightning-fast digital CAN signal down to the modulators by the wheels. Those modulators act as the physical muscle, opening up the pneumatic valves and rushing compressed air to the brakes for a perfectly safe, controlled stop. But all this brings up a pretty fascinating question. How do we take all of this incredibly advanced digital logic and apply it to something as ridiculously simple as rolling down a window or turning on a reading light inside the cab? Well, let's explore that in Section 3, Cab Comfort and Lighting Control, specifically digital doorways and mini furnaces. So back in the day, controlling the passenger window from the driver's seat meant you had to run dozens of thick copper wires straight through the door hinges. And obviously, those would eventually bend and snap from the door opening and closing over the years. But today, it's basically just a simple digital text message. You press the button, your driver door module sends a quick message through the central gateway over to the passenger door module, and that local module physically powers the window motor. Mercedes literally replaced dozens of failure-prone wires with just 4 thin ones. Talk about a massive upgrade.
And for those long overnight stays, we have the ZHE module, which acts as this brilliant little mini furnace. If a driver is sleeping in the cab, idling a massive 12-liter engine all night long wastes a ton of fuel and is terrible for the environment.
Instead, this tiny, independent diesel burner heats the engine coolant and then digitally commands the climate control system to kick on the interior blower fan. So the driver stays totally warm, the engine block stays perfectly preheated for the morning start, and the main engine stays completely off.
Even the suspension and lighting systems use this localized logic now. For instance, the air suspension module reads physical axle height sensors and instantly shoots air into the pneumatic bags to keep the truck perfectly level, like when you're backing under a super heavy trailer. And for the lighting, instead of running heavy copper bundles the entire length of the chassis, a single digital wire just tells the rear module to activate the brake lights. And that localized module provides the power on its own. It's incredibly efficient.
Okay, so this isolated rolling network is clearly incredibly smart, saving a ton of weight and massively increasing reliability. But how on earth does the truck report its status to the fleet managers or environmental agencies back at headquarters?
That brings us to Section 4, Telematics and Exhaust Emissions. Let's look at the Big Brother modules. First up is the After Treatment Control Module, or ACM, which essentially acts as the brain for a miniature chemical plant that is literally bolted to the chassis to clean up the exhaust. It monitors absolutely everything: gas temps, filter pressure, NOx levels. And it's so critical for meeting modern environmental standards that if it detects the truck is failing emissions or say you run out of AdBlue fluid, it doesn't just casually turn on a warning light. Nope, it will send a priority message right over the CAN bus to digitally force the engine to slow down to a crawling 20 kilometers per hour until you get it fixed. It plays absolutely no games.
Then we've got the Fleetboard Telematics module. Because this thing taps directly into that central gateway we talked about earlier, it effectively turns the entire Actros into a giant data node. It knows exactly what the truck is doing at all times. Say a fault code triggers while the truck is cruising down the highway. This module can automatically package that data and send it directly to the cloud via cellular networks. It basically emails the mechanics so they know exactly what parts to grab before the truck even rolls back into the yard. It's a total game changer for reducing downtime.
Finally, let's wrap up with Section 5, the CAN Bus Symphony, where we bring it all together.
Think about what happens when a driver taps the brake pedal today. It's no longer just one isolated system doing the work. The brake module instantly calculates the stopping force, the instrument cluster throws up a digital warning, the engine module cuts the RPMs, the gearbox preps for a downshift, and the retarder kicks in for auxiliary braking. All of this happens almost simultaneously. It is quite literally a perfect digital symphony, where the engine, transmission, brakes, and dashboard all react together in a fraction of a second to keep everyone on the road totally safe. So by completely stripping away those thick, heavy copper wires and physical steel cables and replacing them with these sleek 4-wire CAN bus networks and localized electronic modules, modern heavy machinery has been fundamentally transformed. The Mercedes-Benz Actros isn't just a mechanical beast of burden anymore, it has truly become a highly sophisticated, interconnected, rolling digital network.
And you know, all of this leaves us with one final, incredibly fascinating thought to chew on. When these interconnected modules are already smart enough to execute a perfect digital symphony on their own, managing engine torque, executing flawless shifts, leveling the suspension, and making split-second braking calculations, what happens to the transport industry when they no longer need a human driver at all? Thanks so much for exploring this remarkable explainer with me, and definitely keep questioning the technology driving the world around you.